The next few slides I'm going to be talking about is a little bit, I guess, where 3D printing is heading over the very, very near future. So future applications of 3D printing. And I think this is something that's surprising because we're talking about future applications, but a lot of them are actually already starting to happen today. And the first one is 3D printing houses. And this has gotten a lot of press over the last few years. So I've got a little video clip that shows the principles of how a house would be 3D printed. And in fact, it works on exactly the same principle as the machine we see down the back over there. In this case, it's squeezing concrete out of a tube. So think of it like toothpaste. And you're squeezing toothpaste out of a toothpaste tube, and you're drawing with concrete. So that's what the machine is doing here. It's drawing, in this case, the floor first and just squeezing out concrete bit by bit to draw the floor. Once the floor is finished, it'll start printing the walls. And again, it's just a straightforward drawing process. Here we go, and it's just squeezing out concrete, and layer by layer by layer by layer, it's going to print the house. So for those of you who don't understand that layer upon layer upon layer process yet, this really shows it beautifully. Now, when you're printing with concrete or with this particular technology, you need something called support material. So bits that overhang. So if you imagine on top of the doors and the windows, well, you can't print in air. The concrete's just going to collapse. So most of the printers, like the one at the back over there, use something called support material, where they put on a sacrificial material that you break off afterwards. This technology, contour crafting, they've come up with a slightly different method. You'll see on the right-hand side, we've got another green robot waiting patiently in the wings. And here it goes, picks up beams, places above the doors and the windows, just so that it's got something to print on by the time you get to the next level. And then it keeps printing, away you go. So this is Prof. Koshnevis from the University of Southern California. He's been working this. He's probably one of the earlier researchers looking at 3D printing houses. Probably close to 18 or 20 years now he's been working on this. In this case, they're printing a whole row of houses, and these could be developing country or emergency housing, or it could be luxury housing. There's no restriction on that. But just to show you where the machines are at in reality today, next little video clip is in his lab, a little baby machine that's doing exactly what you saw in the previous clip, but printing in clay. So it's just squeezing out clay and layer by layer by layer depositing ribbons of clay. Very much the same as pottery. If you do pottery with snakes of clay, the same general principle as that. So in this case, it's doing a 3-leaf clover shape. And here we go, it jumps up and second layer starts. And it keeps going until it's finished. And in a few seconds, we're going to see the video clip is going to jump to a bigger machine in his lab doing exactly the same thing you see here, but in concrete. So just squeezing concrete out of a pipe and laying it out layer by layer by layer. In this case, it's got a paddle on the outside, making it nice and smooth. On the inside, we don't care because that's where insulation or electrics and stuff is going to go. So here we go, the same big machine printing in his lab in concrete. Now, this is special concrete with chemicals in it, so it doesn't slump when you print it. So, as I said, he's been working on this for a long, long time, and his prediction is once the technology is mature, 48 hours to print a house ready to move into. That's with plumbing, with electronics. So on his video, on his website, there are animations showing conceptual modular electric systems, modular water systems, and so on. So, as I said, 48 hours ready to move into. The Chinese saw this and said that's not good enough, and they printed 10 houses in 24 hours because they can. Now, a little bit differently. So here they printed what you see on the bottom right there. They printed the sections of the house in a warehouse, trucked them to site, and then glued them together on site. So a somewhat different approach. But since then, in the Philippines, in Manila, they printed out a hotel villa, where they printed out the entire hotel villa exactly as you saw on the previous video clip. And again, probably took about a bit more than 24 hours. It was probably more like a week to get it all done. But that's still pretty incredible when you think about the speed at which you can print these sorts of things. So the technology is not commercially viable today, but it will be very soon. And just for fun, these are some students we had last semester at Lund who printed in concrete. We had a spare ABB robot, so we designed a little 3D print head, and they printed. The idea was a mobile street art or street furniture printer, where you'd wheel it somewhere in a street and it would print some street furniture or some street art. You'd then wheel it somewhere else and it would print somewhere else. This is the first version, and you can see it's pretty rough, but it did work. And we're now working on adding the paddles to make it smooth and make it pretty. So all going well, by the end of this year, we'll have a much better version. And we're currently collaborating with Denmark and France. And the idea will be by the end of the year, can we print a bicycle shed? So a little baby house to show that the technology is usable. So we'll see, watch this space, we'll see where that goes. Next big area of research is nano printing. So this is, well, we didn't get the video there, but never mind. So this is the idea is inside your bloodstream, having these little nanobots, these little robots inside your bloodstream swimming around, keeping you healthy. They might be eating cancerous cells, for example. So this is very much in the science fictional realm today. But it's sort of the extreme. Printing houses on the macro level, now we're talking on the nano level. But I thought this was interesting just to show you where they're at in terms of printing small-sized objects. So what we see on the bottom left is the Nano Bull. So it's by Professor Kawata in Japan. It's a little Spanish fighting bull, 3D printed, 1/10 of a human hair in size. I mean, the fact that you need a microscope to see it tells you just how small it is. So it gives you the other extreme of small size printing. And what you see on the right there is the first 3D printed micro machine. It's a bit hard to see. Just off the picture, we have a square frame, then we have a spring, and we have a suction cup. And when you shine a laser on it, when you excite it with a laser, the suction cup releases, the spring shortens, and it moves along. So it crawls along like an inchworm. So it's nowhere near like a nanobot that would keep you healthy, and that we'll see in the future, but it's the first 3D printed micro machine that is getting near that very, very small scale. So it gives you an idea as to where the extremes are in terms of the large size and the very, very small size. So 3D printing houses is a growing area around the world. So in Umea University, they're now trying to print in cellulose to print a house. It's a growing area of research all around the world. Nano printing as well. The Koreans are doing huge work. They're actually now printing at the nano scale. They haven't printed anything useful yet, but they're printing at the nano scale. So they are down to that small size. But possibly one of the biggest growing areas of research in 3D printing would have to be bioprinting. And the idea with bioprinting is what it sounds like. It's printing tissue and organs. So in this case, what you see on the right there is they're using an inkjet printer and they're printing with stem cells. And with the stem cells, they're printing them out layer by layer by layer, laying them out in the shape they need to be. And then the stem cells get incubated, and over the next 4 to 6 weeks, they become what they're supposed to become. And this is happening around the world. So today, this is Anthony Atala at Wake Forest University, is probably one of the pioneers and the leaders in this area. Commercially today, they've got a company called Tenjon where they're printing bladders. So from your own stem cells, they will print you out a bladder that they can implant straight back into you. And because it's from your own stem cells, the risk of rejection is greatly lowered. They've done trachea, they've done heart valves, they've done all sorts of what I would call today simple tissue replacements that have been grown in a lab using 3D printing technologies. Two ways they do it: either they print directly with the cells, or they print a biodegradable plastic scaffold, like a sponge, I guess, and they seed it with the stem cells, and then over the next 6 weeks, as the stem cells grow into what they're supposed to grow, at the same rate, the plastic is dissolving, so 6 weeks later, you're left with just tissue and no polymer. I mean, that is incredible. Think about it, being able to grow tissues and organs. And it's always a fun question to ask, students the ethical questions about bioprinting, because we haven't even started to think about the ethics of it. And the fun one to ask students, should you be able to print yourself out a spare body to keep in the refrigerator just in case? And there was a movie called The Island where they have clones on an island as spare parts for rich people. And you start to think, there's questions like that. Should you be able to print yourself out a better organ than your old one? To me, the answer is obviously yes, but I guarantee you there will be reasons why that's not a good thing. I mean, think of the Olympics we'd have. That would be cool. So, bioprinting, this is probably the fastest growing area of research around the world. Now, top left, there's Chalmers have now printed an ear. So 3D printing, this was about 2 years ago where they 3D printed an ear using the same technology. In this case, it was a scaffold, seeded with the stem cells, and grew it into an ear. So, like as I said, it is happening around the world. And I'm very hopeful that within my lifetime, they will be able to do more complex organs. So today, very simple organs, essentially think of them as skin. If you think of a heart valve or a bladder, it's very, very simple. What they cannot do today yet is vascularization. So it's all the blood vessels that are in a complex organs. Once they can break that, once they can solve that problem, I think very, very quickly they will get to the stage where they can print much more complex organs like livers, kidneys, hearts, and so on. So whether that happens in my lifetime, I'm not entirely sure. I hope so, because I'm pretty sure I'm going to need a liver before too long. But yeah, it is happening. It is growing around the world. And then the final area I'm going to leave you with, which again is a growing area around the world, is printing food. Oh, actually, conductive printing. This is probably, from a design point of view, from a product development point of view, this is probably the one that's got the most potential to change consumer product and industrial products, being able to print electronics. So today, they can print wires. So what you see on the right there, Voxelate is an American company. They've just got a huge amount of funding for this. They can print conductive polymers or silver inks into 3D printed objects. And what you see on the top right, left there is a little mini quadcopter, like a little drone, 3D printed with all the wiring printed as part of it. And they drop in chips and print onto the chips to get the conductive things happening. Some of the work we've been doing both in New Zealand and here in that area is printing curved layers. So currently all the 3D printers print with flat layers of material. One of the problems if you're printing electronics, guaranteeing the conductivity between the layers could be a challenge. So it may make good contact, it may not make such good contact, depending on how well it's bonded together. So the idea is we want to be able to print curved layers of material. That way we can guarantee conductivity. And we've had some success in that. We've been printing parts with curved layers. We have been printing parts with dual curved materials, where we've printed ABS and ABS doped with carbon black that is slightly conductive. It's not very conductive, but it's proof of concept. It shows that it can be done. So again, this will be ongoing work in this area. And then the final area of future development is 3D printing food printers. And this is the MIT Labs cornucopia project. Concept is very, very simple. That's on the top left, you can see it there. All those cans on the top are the raw ingredients. Vitamins, coloring agents, soya, whatever the base ingredient is going to be. And the concept is simple. You walk up to your refrigerator or your food printer and you say, I'd like a hamburger medium rare. And then from those raw ingredients from the ground up, it prints layer by layer by layer and builds up your food as you go. Print the plate at the same time. Why not? I mean, you can. So printing food today is more or less not happening yet. The only food I know of that has been 3D printed is meat. So a company called Modern Meadow, which is an offshoot of Organova, who does a lot of bioprinting, they've printed meat the same way as they print tissues and organs. So it's with bovine stem cells, print them out in the right formation, and then they grow into being meat. And a few years ago, they had a hamburger, the first 3D printed hamburger on a British chef program where they ate the first 3D printed hamburger. And from memory, it was about $30,000 for the hamburger. Science, but it was a nice case study. But 3D printing with food is happening all around the world. So things like sugar, very easy to print with sugar. And this is full color sugar printing. You spread a layer of sugar, you use an inkjet printer to print glue or binder onto it in color, and you can make incredible wedding cake toppers, for example. Pasta, lots of people printing pasta, printing pizza, all sorts of things like that. But it's not really printing food, it's printing with food. So it's any food you can put in a syringe and squeeze out, you can 3D print with. Another example of that is chocolate. Very, very popular. So we've got a couple of students working on chocolate printers at LT Hall. This was a nice one in the Fab Cafe in Shibuya about 2.5 years ago, Valentine's, which was yesterday, and they had a special promotion where you bought a box of chocolates for your boyfriend or girlfriend, and there was a mini-me head of yourself looking out of it. So slightly scary in this case, maybe. Yeah. And the Eat Your Face machine, MIT Media Lab. So as I said, chocolate is a very, very easy material to print with. And it is happening around the world where people are trying to develop printers for food printing. And just recently, they had a food conference in Amsterdam, a 3D printed food conference, where the entire conference was about 3D printing food. So as I said, these are just some of the areas that 3D printing is growing into. And as I said, it's in the future, but it's actually all starting to happen now. So the next 5 years, I guarantee you, are going to be incredibly exciting, both for the future, but also for the current things that are being used for. We need more materials. We need better materials. We need more applications of what you can use this for. Companies like Tetra Pak currently are struggling to say, oh, what can we do with it? And we're starting to find applications. But the more we work with this area, the better off we're going to be as companies, as industries, to find out useful things we can do this that really add value to what we do. So probably I'd leave you with just the thought of that, 3D printing, the only way to get to terms with it is to use it. You've got some MakerBots floating around Tetra Pak. By all means, go print yourself an iPhone case. Scan yourself and print a mini-me. Play with it. You play with it, you use it, you'll get used to it, you'll start to understand what they can do. So with that, I'll thank you.